Hi, welcome back to Mrs. Ogram's Maths. We are working through the D&D resources worked solutions in this series of videos. So thank you to D&D resources for allowing me to use their materials in this way. I have put a link to their website in the video description. You can go online and order copies of their resources or get their ebooks. They are extremely helpful revision for the externals. So this one is looking at the worked solutions for the integration standard, and it's practice assessment number 5. So let's take a look at integrating this first expression. Now cos integrates to sine, so we'll switch that straight away. The inside stays as a 3x. What we need to do is reverse chain rule. Because we've got that 3 inside, we're going to divide by the 3. So that'll be 2/3 sine 3x. Now cosec is on your formula sheet. If we integrate cosec, it goes to minus tan. So if we integrate minus cosec, it'll go to positive, sorry, not tan, cot, positive cot. So cosec squared goes to cot. The 2x remains as it is. It's going to become a positive, and the 3 there, again, gets divided by the 2 because we are doing reverse chain rule. And then finish with a plus c. For part B, we are given a function for acceleration. I'm going to write it in line like this, because to get the velocity from that we need to integrate. So we are integrating this function here with respect to t. So we raise the power by 1, divide by the new power, will make it a minus 2 at the front where we had a 2 before, and we would divide through by the derivative of the inside there, but that's just a 1, so it doesn't change anything here, and then we have a plus c. Right, now we're told that the initial velocity of the particle is 0. So v of 0 equals minus 2 over 0 plus 3 plus c, and that's going to be equal to 0. So when t is 0, this whole thing equals 0. So that means that c is equal to 2/3. Then we want to find the velocity of the particle at 5 seconds. So v of 5 will be minus 2 over 5 plus 3 plus 2/3. So negative 2 over 8 plus 2 over 3 gives us 5/12, but we would usually do that in decimals. So let's write that as a, actually I'll put them both in. So 5 over 12, which is equal to 0.417. And we're measuring it in meters per second. Okay, now we're finding the shaded area on this one. First, we need to find the values of the x coordinates. We've been given the y coordinates. We need to work out these two numbers here. I think the fastest way to get that will be using equation solver, because we're going to need to do it twice. So let's just delete that out. We're doing 5x minus 2 divided by x plus 2. Now, first of all, let's set that equal to 3 for the first one and solve. So when y is 3, x is 4. So that number there is a 4. When y is 4, let's go back and change that. So up here, let's pop it into, instead of making it equal to 3 at the end, let's make it equal 4 and solve. We've got x is 10. Okay, so now we're going to integrate between 4 and 10 of 5x minus 2 over x plus 2. Now we can't integrate that function itself as it is, so we need to turn it into something else. We're going to do a bit of algebraic juggling. So on the top, if I introduce the denominator and times it by 5 so that I make sure I get the 5x, that would give me 5x plus 10, but I need to make it equal to 5x minus 2. So I'd need to take off 12 for that to be true and put it all over x plus 2. What that enables me to do is then separate those two fractions, so I can write them separately as over x plus 2 and over x plus 2, which makes that cancel, so we just have a 5. So now if I integrate 5, I will get 5x, and if I integrate minus 12 x plus 2, that's going to be the natural log. So the 12, just bring that out as a constant, so that's minus 12, but 1 over x plus 2, if we integrate that, is the natural log of x plus 2. And we're doing that between 4 and 10. Okay, now we can sub in those numbers and we get the area. So the area is equal to 50 minus 12 log 12, take away 20 minus 12 log 6. Which gives us 21.68 units squared. Now we've got quite a bit going on in part D. We have this derivative equation here, and from that we need to be able to work out a equation in y equals something so that we can find this distance here between the y coordinates for A and B. So let's get to work with that differential equation. If we bring the y up to the left-hand side, make it y dy, and the x over to the right-hand side, so we have the dx over there, and we can integrate both sides. So that was called separating variables. That's the method I'm using just now. Now if we integrate the left, we get y squared over 2, and if we integrate the right, sine integrates to a minus cos, and then we divide through by the 2 that's in there, and plus c. Now to carry on with this one, I actually had to go away and do some checking because there wasn't quite enough information for the next bit, and I believe there to be an error with the diagram that's drawn here, and it should actually look like this. The answer that's given in the book will actually look like this, where we have this peak at pi by 2 happening where y is 2. So I'm going to use that to carry on with. So these numbers don't quite match up on the y-axis here. The peak here actually happens at 2 to give the answer that is intended for this question. I think there was probably just a minor mistake in formatting this graph. Okay, so when x is pi by 2, y is equal to 2. So we get 2 squared over 2 is equal to minus a half cos of 2 times pi by 2 plus c. So cos of pi is equal to minus 1. Times it by minus a half. We will have a half plus c on the right. 2 squared is 4, divided by 2 is 2. So c is 2 minus a half, c is 1.5. Then we want to work out the vertical distance at this point between A and B, and that is when x is pi by 3. Let's just switch up the colour a bit actually. We'll do our distance here. So vertical distance is what we're looking for now. We work out the y coordinate at A. We're going to put in x is pi by 3 into our y equation. So y squared over 2 is equal to minus a half cos of 2 times pi by 3 plus 1.5. So minus 0.5 cos 2 pi divided by 3 plus 1.5. Now we need to get the y value from there. So y squared over 2 is equal to 1.75. So we've got to times that by 2, and then we find the square root of that answer. So that gives us a 1.87. So the vertical distance, in fact, let's just pull this bit down here, will be twice that y coordinate. So it's 3.74. For part E here, we have Newton's law of cooling question, where the rate at which something cools down is proportional to the temperature and the temperature of the thing and the temperature of the surrounding area. So let's pick out some information. We've got the outside temperature is 23 degrees, and the rate at which that temperature of the ice block is melting we write as dt by dt. So the temperature of the ice block is proportional to, or rather the rate at which the temperature is changing is proportional to the difference between the temperature of the ice block and the temperature of the surrounding environment, which is 23. So we write that as temperature of the block minus 23 degrees. It's going to be multiplied by some constant k to represent that it's proportional to that rate. So now what we would do is separate the variables. So we have 1 over t minus 23 dt is equal to k dt like this, and we integrate both sides, which gives us the natural log of t minus 23 is equal to kt plus c. And I'll just come up over here now. We want something that's an equation of t equals. So t minus 23, if we raise both sides to the power of e, it would be e to the kt plus c. Well, this can be rearranged to be a e to the kt just by using Power's rules. And so the temperature will be a e to the kt plus 23. Now part 2 gives us some more information. We've got the initial temperature at minus 16, and after 40 seconds it's minus 8. That helps us to work out the constants that we have in this equation just here. So when t is 0, t, which is a e to the k times t, would be 0 plus 23 will be equal to minus 16. So e to the 0 is just 1, therefore a is minus 16, take off 23. Making it minus 39. Okay, next, when t is 40, our temperature, which is a e to the kt, where a we've just worked out is minus 39, e to the k times 40, so that'll be 40k, plus 23 is going to be equal to minus 8. So then minus 39 e to the 40k will be minus 8 plus 23. Oh no, minus 23, which is minus 31. E to the 40k will be minus 31 divided by minus 39. That's 0.795. So 40k will be natural log of that. So k will be 1/40th times the natural log of 31 over 39. I'm going to write it like that so I don't lose any accuracy. and pop it into the calculator here, we would do log of that answer and then divide it by 40. And then the last step is to work out when will the temperature get to 0. So we're popping into our equation where a is minus 39. We have e to the k, which was 1/40th natural log 31 over 39 times by t. T is what we're going to work out. And then plus 23. So I'm just referring back up to this equation here and putting in the a and the k. And we want to know, when does that make 0? So we'll have minus 23 over minus 39. Let's start with that. As I take the 23 over to the right, then divide by the 39. And then we would do the natural log of that. And then I would divide it through by k, which is what I've got as my most recent answer on the calculator. So I'm going to pop that in like this. So t equals 92 seconds. You could also put this into equation solver if you want to just save yourself a bit of the manual work. And there it is, all on the one page. For 2a, let's begin with writing this in line. So we have 5x plus 4 to the half. So if we're integrating that, we are going to raise the power by 1. So that'll be 3 over 2. We divide by the new power. So that means timesing by 2/3. We also need to divide through by the 5. So if we divide through by the 5, that 3 times by 5 becomes 15, and then plus c. Okay, solving this differential equation, we are separating variables. So 3y squared dy is equal to minus 8x dx by cross multiplying. We're going to integrate each side. So 3y squared becomes y cubed, and then divide by the 3. And we have x squared, so minus 8 divided by 2 is minus 4. And then plus c. Now when x is 2, we have minus, oh, I've got that the wrong way around. When y is 2, we get 2 cubed. We have x is 1. So we have 8 is equal to minus 4 plus c. C must be 12, and y cubed is equal to minus 4x squared plus 12. For this area, we need to first get the point of intersection just there. So I am going to pop that into the graphing portion of the calculator. Let's just delete that out that was in there. So we have e to the 0.5x, and we have 4 e to the 0.25x. I'm just going to pop that in brackets to make sure that it does put the x in the power. We'll do the same on the top one. Okay, and draw. And we're going to need to just shift the view window a little bit. So I've reset that. Now we can use gsolve and find the intersection point, and that tells us it happens when x is 5.55. So now we're going to integrate between 0 and 5.545 of the difference of those functions. So 4e to the 0.25x minus e to the 0.5x. So integrating e to the 0.25x. Let's just go back to our calculator. Here we go. So the e part doesn't change, but we do need to divide through by the derivative of the inside. So that's 4 divided by 0.25 gives us a 16. Then we have e to the 0.5x. Again, we're going to do 1 divided by 0.5, which is going to be a 2. Pop in a 0 and a 5.545. Okay, so 16 e to the 0.25, let me just pop it in some brackets, times by 5.545 minus 2 e to the 0.5 times 5.45, 545. And then that gives us a 31.999. Let's just write all of that in. We're going to subtract, if we put a 0 in, we will have 16 e to the 0 is just going to be 1 on both of those terms, so it's 16 minus 2, so we're taking off 14. And that rounds to 18. For part D, the top is exactly the derivative of the bottom, so integrating that gives us log of the bottom. And we're going to do that between k and 2k and set it equal to natural log of 5. So we have natural log of 2k in this is going to become 8k minus 1 minus natural log of 4k minus 1 equals log 5. Now using our log laws, this is the same as 8k minus 1 over 4k minus 1. So therefore 8k minus 1 over 4k minus 1 equals 5. We have 8k minus 1 equals 20k minus 5. So then that'll give us minus 1 plus 5 is going to be 4, and 20 minus 8 is 12, so k is equal to 4 over 12, which is 1/3. Okay, for this curve, we've got that it cuts the x-axis at minus a quarter. So we've got x is minus a quarter just here. We've got the gradient function, so we can work out the function of the curve itself by integrating. Now this is going to be 2 4x plus 1 to the minus a half. So if we integrate, increase the power by 1, gives us a half. Divide by the new power, so that's 2 divided by a half gives us a 4, but then we also need to divide by the 4 that's on the inside, so it just ends up being 4x plus 1 to the half plus c. Now we know that when x is minus a quarter, y is 0. So f of minus a quarter is 4 times minus a quarter is minus 1, plus 1 is a half, plus c, and that's going to be equal to 0. Which means that minus 1 plus 1, well, that's just a 0, so c has to be 0. And f of x just equals 4x plus 1 to the half. Now to think about the line, it makes a normal to the curve at x equals 6. So at this point here, x is 6. So when x is 6, we will have f of 6. The value of the y coordinate at that point, so we can put that into our f of x equation. So 4 times 6 is 24, plus 1 is 5, and then we square root it, so we've got a y coordinate of 5. We can also find the gradient when x is 6 by putting it into this original function that we were given. So again, 4 times 6 is 24, plus 1 is 25, square root that, we have 5. So the gradient is 2/5. Now that gives us the gradient of the tangent, so the gradient of the normal will be the negative reciprocal of that. From there we can make the equation of the line y minus 1 equals mx minus x1 using the coordinate 6, 5. Actually, I'll write that up here, 6, 5. So y minus y1, the y coordinate is 5. The gradient m is minus 5 over 2. The x coordinate is 6, and that's giving us the equation of this straight line, the normal to the curve. So now y is equal to minus 5x over 2 times by 5. No, wait. Not times by 5, I'm thinking ahead too much. So, but with the next bit, we'll have minus 5 times minus 6 gives us plus 30. Divided by 2 will give me a plus 15. Then bring the minus 5 over to add that on. We end up with a plus 20. And we can use that to work out what point that line gets down to the x-axis. And that'll happen when y equals 0. So if we set that equation equal to 0, we will have x would then be to do minus 20 divided by minus 5 over 2. So x is 8. Okay, now we've got all the pieces that we need. We can work on the area. I'm going to split it into these two pieces. So the area now is going to be going between minus a quarter and 6 for the integrating the f of x function. And then we'll add on the area of the triangle, which will be half times the base, which is 2, because it's the gap here between 6 and 8, times the height, which is 5. Okay, now if we are to integrate this 4x plus 1 to the half, we raise the power by 1. That gives us a 3 over 2. Divide by the new power gives us a timesing by 2/3. We also need to divide through by the 4, so that turns that 3 into a 12. And we are doing that between minus a quarter and 6, and then we will add on the 5 for the area of the triangle just here. What I didn't spot, that 2 over 12 can be simplified to 1/6. Okay, so let's put 6 in. So 4 times 6 plus 1 is 25. 25 to the power of 3 over 2 is 125, and divided by 6 is not so easy to work out. Let's just pop that in as 125 minus over 6. Now minus a quarter, I'm going to do minus 0.25, times it by 4, plus 1. I've made a mistake. Minus 0.25 times by 4, I accidentally hit the 5, plus 1 gives us a 0. And then add on the 5. So in total, we've got 125 divided by 6 plus 5. Our area is 25.83 units squared. All right, question 3. We need to separate this integral into two different pieces. So it's 12x over x, which is going to cancel, and minus 5 over x. So if we integrate the 12, we get 12x, and if we integrate 5 over x, it's 5 log x plus c. For part B, we need to do Simpson's rule. I'm going to use the table function just to save me a bit of time. Let's delete out those functions that were in there already. Okay, now the function that I'm putting in is the natural log of 1 plus x squared. Now the settings, I want to start at 2.5, end at 4 and go up in steps of 0.5 so that I can fill in the rest of the pieces in this bit of table. And let's see the table. Okay, so we have 1.981, 2.3025, 2.5839 and 2.8332. Okay, now Simpson's rule. We go 0.5 for the gaps here. So H, and again, this is on your formula sheet, so I'm just reading off of there. So whatever these steps are, that's your H. So they're going up in 0.5s. The H then gets divided by 3, and then we take the first Y term and the last one, we add them together, so 0.693 plus 2.833 will do, and then we add on 4 lots of, actually let's do some colour here, colour code things, so 4 lots of these 3, so 1.179 plus 1.981 plus 2.583, and then add on 2 lots of these ones, 1.609 and 2.3025. And I'm going to pause while I pop that in the calculator because it's going to take a bit of time. And it comes to 5.72. For part C, we've got a decay question where we're talking about the blood alcohol level. So I'm going to talk about that as being B. So the rate at which that blood alcohol is changing over time is proportional to the blood alcohol that he has to begin with. So now we separate the variables. We have 1 over B dB is equal to K dt. Integrate both sides. We'll have log of B is equal to log K plus, no, not log K, KT plus C. So then B is equal to e to the KT plus C, which can be written as A e to the KT. Now we're told when he first uses the breathalyzer, he's got 50 as his level of blood alcohol. So when T equals 0, B equals 50. So AE to the 0 is equal to 50. E to the 0 is 1, so A equals 50. The next bit of useful information is that it reduces by 30% in the first hour. So when T is 1, if we're doing 30% less on 50, we can times it by 0.7. So we've got a rate of an amount of 35 after 1 hour. So where we had A e to the KT, we've got 50 for the A. Oops, 50 in place of the A, then e to the KT, so T is 1, so 50 e to the K is equal to 35. So now we can work out K. 35 divided by 50, and then take the natural log of it. Oops, let's just go back one. So 30 divided by 50, 35 divided by 50, and natural log of that answer gives me minus 0.357. We want to know when does that reduce to being 20 or less. So we want to set our equation of A e to the KT. So 50 for A, e to the KT, so minus 0.357 when does that get to be equal to 20? Oh, I missed a t that goes in there. So if we do 20 divided by 50, and we take log of that answer, then we'll get minus 0.357t is equal to minus 0.91629. So let's divide that by the negative 0.357. We've got t is equal to 2.57 hours. That's how long he will need to wait. For part D, we are doing the area under a curve, so we go between 1 and 6, and we're integrating 3e to the x over e to the x plus 1 plus x over 3 with respect to x. Okay, this first term, we have the top is a multiple of the derivative of the bottom, which means that our answer is the natural log of the bottom, but then we need to see what we have to multiply it by. If I was to differentiate e to the x, I'd get e to the x, so we need to make this 3 times bigger. And then a third of x, if we integrate that, is going to be x squared divided by 6. So now let's pop in our limits. So we have 3 log of e to the 6 plus 1 plus 36 over 6. So that cancels to just be 6. Take away 3 log e to the 1 plus 1 minus a 6. And pop it in the calculator. I'll just pause while I do that. I did make one tiny little mistake just then. That should have been a plus. I've just fixed that up. So it's 19.9 for our area. Okay, to find this volume, we are doing pi times the integral between a and b, so that's 0 and pi by 3 from these values here. Then we do the y function squared, so that's tan x plus 1 squared. So that would be to integrate between 0 and pi by 3. We'll get a tan, expanding that bracket, we get a tan squared x plus 2 tan x plus 1. Now at the moment that's not in things that are easy to integrate. They're not on your formula sheet directly as they are, but what we can do is recognize that tan squared plus 1, that is an identity that's on your formula sheet. So that can become sec squared. So this will be pi 0 to pi by 3. Tan squared x plus 1 is sec squared x. And 2 tan x is 2 sine x over cos x. These bits we can actually integrate. So we'll do pi. Sec squared integrates directly into tan x. Sine and cos are derivatives of each other, so the top is a multiple of the derivative of the bottom. Now if we differentiate cos x, we get minus sine x, and when the top is the derivative of the bottom, it's the natural log. So bring out the 2, and now we've got natural log of the bottom, cos x, for pi by 3 and 0. Okay, then we're going to substitute in. So pi, tan of pi by 3 minus 2 log times cos of pi by 3, and then take away tan 0 and minus 2 log cos 0. And I'll just pop that all into the calculator. That comes to 9.8 units cubed, because we're doing a volume. All right, that's the end of this paper. If you found it helpful, please like, subscribe, or comment, and check out my homepage for other things that you might find useful.